So thank you for introducing yourselves. I also want to introduce you to the rest of the CRAB team. The CRAB team is really founded on a core of trained and engaged volunteers working all across inland Washington waters. We have a number here. This is our South Sound crew at Butterball Cove, and we have Kala Point out here near Port Townsend, and then a number in Island County as well. So this is, and this year we're going to be engaging even more volunteers, and this is really a very large-scale effort that relies on a lot of manpower and a lot of people with boots in the mud having a good time. So hopefully you'll get the chance to meet some of these folks at some point in the future, but it's a really great community we're really fortunate to be a part of. So I want to lay out the plan for today, which you can also see on the little board flip chart over there. I'm going to spend what remains of the next hour giving you a little bit of background on green crab, the history of the global invasion, and a little bit about what we found in 2015. That was our pilot year. We had a small subset of sites, and we did collect a little bit of data. Now we're scaling up. And then Sean, in the second session this morning, will give you a rodeo roundup of diversity of pocket estuaries. So we're not just looking for green crabs, we're looking at everything that lives in the habitats that we're monitoring, and so we're going to learn how to identify those as well. And we brought lots of shells and specimens, and we have lots of pictures that you'll get an opportunity to play with, because it is the fun part. We'll break for lunch, and afterwards we'll start talking about the protocols that we use to monitor these habitats. We have two main sections of protocol, one of which is baited trapping, and then the other of which is a shoreline survey, where we look for molts and we also assess some shoreline features such as vegetation. And for each of those, I'm going to talk through the protocol first, and then we'll break into small groups and we'll practice it, and we'll probably go out on in the grass where we have a little bit more space, and we can set out some mock traps and talk about how we would walk through collecting the data. The last half hour we'd really like to devote to a conversation about if you're interested in volunteering, what site you would like to work at, and forming teams. So we don't expect anybody to take on this monitoring by themselves. We found from last year that the best teams are groups of 3 to 5 people who can support each other if somebody is sick one week or has a vacation, so that nobody is ever working alone. In addition, it makes the work a lot more fun, and it makes it go faster if you have at least 3 people on site. So forming groups and choosing sites. Another key step at the end of the day will be filling out the second page of that assessment, just to see if we did manage to teach you anything. And then lastly, next steps. So after we talk through everything today, it's a lot of information. So one of the really important parts of getting going as a volunteer is actually us visiting the site with you for the very first time that you go out there. We join you at the site, we get you oriented to the landscape and the tides, and walk through the protocol with you on the first day of sampling, so that any outstanding questions that you have, that's a chance to have our undivided attention and resolve any sort of questions. So that's the general plan for today. You should always feel free to use the bathroom whenever you need to and interrupt me with any questions, or to grab coffee, etc. Any questions so far? So to get started on the reason that we're here today, this is our species of concern, the European green crab. The Latin name for European green crab is Carcinus manus. The fun fact is here, manus means raving mad, and Carcinus is sort of the Latin for crab, so this is a raving mad crab. This crab the reason we're concerned is that it's often listed as one of the world's worst invasive species. And the group that came up with that is the International Union for the Conservation of Nature. And they have an invasive species specialist group. So these are the smartest invasion biologists in the world. And they sat down and said, what are the species that are doing the most damage worldwide? And this is that group. And our guy is right here. And it's towards the top, not because it is the worstest, but because this is actually alphabetical by Latin name. So this is sort of a an artifact of that, but you probably recognize several other species that we have here locally. This is a starling. We got a starling here. I encourage you to go to the website for this and just learn about some of these species. It's really pretty interesting history. In any case, ending up on this list of being out of something like 4 million species on the planet, what does it mean to be one of the worst? That's kind of a bum rap. And it's certainly earned the green crab a lot of bad PR with a lot of very end days language about what happens when green crabs show up on your doorstep. But what makes this crab such a bad invasive? And one thing I want to stop and take a second to talk about is when I say bad here, I don't mean the crab is evil or mean-spirited. I'm not meaning to malign its character. This crab is just a crab doing what crabs do and doing what we all try to do, which is just to survive and reproduce and be good at it. Just happens that what we call bad and what this crab is actually very good at is something that's problematic for humans. It causes trouble for us. It's more likely to establish populations outside of its native range. It's more difficult to control those populations when it does, and it's more likely to cause damage to things that we care about, cause economic harm. So that's why it ends up on that list with those other guys of the worst invasives. And in fact, I think a more values-neutral way to think about it is not that it's bad or worst, but that it's actually a very successful invader. It's very good at doing these things. And I'm going to talk through some of the reasons about why it's such a good invader. So first I want to take a second to agree on a consensus definition for invasive species, because it's something that terminology can cause people to trip up. Oops. I want to talk specifically about this crab and why it has been so successful. And then I want to zoom in on our particular geography and talk about what is the real threat level to our shorelines in inland Washington, and is it oversold? And what are we doing about that threat? So we're going to cover that this morning. So first, agreeing on a consensus definition. So it turns out that managers and conservationists and educators and biologists often use different criteria when they use the word invasive species. So we're going to use a consensus definition that comes from the state of Washington, the Revised Code of Washington, that relies on 3 criteria. First, this species is non-native. Now, non-native means that it spent the majority of its evolutionary history outside in a different range, in a different geographic range. And the reason that evolutionary history is important is because that often plays a role in how it interacts with other species. So species interactions evolve together over time, and when you don't share an evolutionary history with another species, you often get surprising and unstable dynamics. Yeah? So this is a question that it's a great question, when a non-native becomes a native. And it depends on who you ask. I suspect in invasion, if you ask, I consider myself an invasion biologist, so I come from the academic side. I would say that it basically doesn't ever become a native, especially along human timescales. If something spends 15,000 years evolving in a different habitat, it doesn't take 100 years for everything else to respond to it in evolutionary time. Sean, I'm curious about your response to this as well. And in terms of how it got here, I would say that the relevant thing is that it could not have made it here, or it would be a vanishingly low probability of arriving in this habitat without human assistance, which is, I think, one of the keys. And so the caveat, as I said, and I think Sean would put himself in the same category of, I'm an academic invasion biologist. The way that plays out in management is often determined very differently. So you can have non-native organisms that people consider non-invasive, in which case it's managed very differently than an invasive. Yeah, like Pacific oysters, I believe they consider naturalized. The second criteria is that it causes economic or environmental harm, so it doesn't have to just impact human economic activities. And the third is that it's capable of spreading to new areas of the state. So note that this definition explicitly excludes agricultural crops. So under this definition, Himalayan blackberry is invasive, as is the apple maggot, but corn and tulips are not. Corn is agronomic, so we value it. It's not invasive. And tulips aren't going to get very far without human help. So some of the sticky parts of this definition is, and some in addition to the question that you just asked, which is a great question, come when we're thinking about this concept of what constitutes harm. Harm is a really subjective thing in terms of what resources we value, what levels of change in the environment we're actually able to detect, and how that changes over time. So just to give you an example of how this has played out here, this is a species that lives right out there. This is non-native dwarf eelgrass, Zostera japonica, Japanese eelgrass. And this is a species that is native to the Western Pacific. But when this first arrived here, whenever that was, it's not really well known when it got here. When it first arrived here, it fell under protection by the state. It was a protected species because it's so closely related to our native eelgrass that it just was in the same genus. So they're so closely related that it was just protected. Then the clam growers discovered that it's bad for business. It makes it hard for them to grow clams on their beds. So they lobbied to have it listed as a noxious weed when it grows on clam beds. And so that was the listing of this species for a while. And now it is listed as a noxious weed everywhere. And so there are different sort of implementations of, even though this species does have positive effects for certain environmental characteristics, it also has some positive, some negative, and so a little bit is just about who has the political will to try to push through a listing change. I do, as a biologist, because based on the criteria that it's not from here, it's capable of spreading, and it does alter ecosystems, so it changes things. Whether that's for the better or for the worse is, to me, less important as to whether it's changing it away from sort of what the native community is.
And it got here because people brought it.
Got here because of oyster culture. So they imported oysters from the Western Pacific. Our Pacific oysters, which make up most of the shellfish industry here, brought over accidentally a lot of non-native species, and this was one of them. Yeah, Bob.
Okay, I have a slight disagreement with your
Sure.
Understanding of its movement out of protected species. I think the clam growers grow clams at the same tide height that Zostera japonica grows.
That's true.
And since it was a protected species, they weren't allowed to disturb it when they wanted to work their clam beds.
Yeah.
It wasn't well, you said interferes with their operation. That's how it interfered with their operation. If it moved, if Zostera japonica
Sure.
moved in, then
That would definitely
disturb it.
be an obstacle, but there is actually research that shows that when this is growing on clam beds, clams can't get to the same density. So the biomass of clam that's harvestable, you're right about that. If this were protected, that would mean clam growers couldn't, couldn't rip it up in the way that they need to space. But if they allow this to invade clam beds, which it can, then the density of clams is actually lower. So the biomass of the harvest is also. You're right about that as well. Yep. Thank you for adding. It doesn't. So the native eelgrass grows deeper, and the clams are, as Bob mentioned, are higher. So there is some spatial separation there. So what makes this green crab so successful at invading? I'm going to walk through a few characteristics. One, it's a pretty small crab. So as an adult, it doesn't get much bigger than 3 inches across the back. That's not super tiny, but it is somewhat small. But of course, like a lot of marine invertebrates, it starts out life a lot smaller. So this is the free-swimming, very first life stage. When it hatches out of an egg, it looks something like this. And this is the stage that is just getting moved around by the currents, and it's most likely to get transported accidentally in ballast water. So ships take on massive amounts of water in ballast tanks to balance their load when they're carrying cargo, and they discharge that at other ports, potentially carrying organisms in it. So you can imagine something that is that small could easily be sucked into a ballast tank and moved across an ocean and then dumped out accidentally. There's been a lot of movement to manage ballast water better. It's probably much better managed than it was even 20 years ago, but there's still opportunities for improvement in that area. So even when green crab grows up to the next life stage, which looks something like this, and Sean likes me to point out that it has legs on both sides of its body. It's just this drawing I think the artist was a little bit lazy. So this is 10 times larger than this. And you can see these guys with the naked eye, but you can imagine moving, as aquaculture, moving equipment and materials from between shellfish beds, and as we move Pacific oysters across the world, a lot of species get moved in there. And specific to the green crab, the seafood shipping used to happen in wooden crates with seaweed as packing material. This seaweed in particular is a favored habitat of this stage of green crab. So you put your lobsters in a crate, you put a bunch of seaweed in there, ship your lobsters across the country, dump the seaweed out on the beach, and there's a lot of baby green crabs you've just introduced into really good habitat. So this is a lot of the ways that green crab has gotten moved, and it's because it's small, it's hard to detect, and it's hard to sort of filter it out and stop it from getting transported accidentally. Green crab is also prolific, again, like a lot of marine invertebrates. I've seen estimates of up to 500,000 eggs per brood. This is a female, and these are her eggs. She's carrying them on her abdomen. Green crabs are also, I guess I would call it gregarious. They're not social like bees or wolves, but they don't mind being crammed in at really high densities. And that's when you start to see the big ecological impacts, when you have a ton of crabs living in a small area. Green crabs have benefited from the fact that they are not picky eaters. So these are some of their favorite foods. We've got some bivalves, and we've got barnacles and crabs and scallops. Primarily, they prefer to be a predator, but they will eat anything else, and they can survive, but also reproduce, being entirely vegetarian on a diet of entirely seaweed. So they're really not choosy eaters. I've made the joke before that I like to think of the green crabs as the Anthony Bourdain of the marine world. This guy, if you haven't seen the show, he goes to just foreign places and he eats whatever they're cooking, and sometimes it's things you never thought were edible. And so this is sort of how green crab is. It just shows up at your dinner table, and it's not going to be rude. It's going to take a sample of everything, and it can survive that way. So that helps it. So this is a creature that primarily lives in estuaries, and that actually benefits it as an invasive, just because a lot of the major shipping centers in the world are in estuaries rather than strictly freshwater or strictly marine. So being near ships that can pick up water and move it around the world just makes it a higher probability that the crab is going to get moved accidentally. It's cryptic. It's good at hiding. As a juvenile, they can change colors slightly as they molt in ways that enable them to match the background. And even as adult, they're really good at blending in with their habitats, especially I told you about this favored seaweed that they have. So this is another way where it just makes it hard to keep them from hitchhiking. If you're looking into a crate of seaweed, even as adults, it's hard to very quickly spot the green crab.
It looks like sargassum.
This is Ascophyllum nodosum. This is an East Coast and Northeast one.
I said looks like.
Yeah, could be that the resolution isn't very high. And then lastly, but certainly not least, this species has a wide environmental tolerance, and this is something we see a lot of times in species that are successful at invading. So to show you just what I mean by that, I'm going to show you the temperature and salinity tolerance for the green crab in comparison to the Dungeness crab. So in terms of temperature, green crabs do just fine, very, very cold and very, very warm. If you spend much time thinking about marine invertebrates, you know that's a pretty warm temperature, 35 Celsius. And Dungeness crabs really need it much cooler. It's a little bit hard to see, but the end of the bar is about right here. They only do well up to about 18 C. Beyond that, they start to get pretty heat stressed. Now, in terms of salinity, green crabs are euryhaline. They can survive to water that is very, very fresh relative to a lot of marine creatures. And indeed, Dungeness crabs are really much more on the marine end of the scale, and certain parts of their life history are particularly sensitive to salinity. So this is just increasing the probability that anywhere they show up is going to be okay for them. The environmental conditions they're going to be able to withstand them because they can tolerate so much. So what all of this has added up to is a species that's really a worldwide invader. This is the native range for the green crab. It extends all the way up to the Baltic and North Seas down to the coast of Morocco on the south end. So that's a pretty broad temperature range if you're thinking about sort of the latitudinal gradient. And this species has dispersed and established in nearly every temperate marine habitat worldwide, including our invasion, which was actually a hopscotch invasion. We can tell from genetics that our green crabs came from the east coast of North America rather than the native range directly. So those secondary invasions can sometimes happen in ways like that. Zooming into the East Coast, this information's a little bit old, but I want to point out that the green crab was first noted in Long Island Sound in 1817. But if you look at these dates, it's been continuing to move up northward on the East Coast, southward as well, but it's still expanding its range northward. This is, like I said, a little outdated, into the Maritimes of Canada. So this is something that doesn't stay put. Those larvae that I showed you that are just swimming around get pushed around on currents and they find new habitats. So this is, and in addition, in areas where it's been present for a bunch of decades, it's becoming more abundant. So it might have been previously rare, but the invasion is continuing to increase in scope because it's becoming more dense in those locations. We have a somewhat similar trajectory on the West Coast here. First discovered on the West Coast in San Francisco Bay in 1989. Like so many invasives on the West Coast, first discovered in San Francisco Bay. In the next decade or so, it mostly just moved out to some of the local embayments nearby, north and south. It's moved a little bit south. However, in 1998, there was a big sweep northward, and it established on the outer coast of BC and Oregon and Washington. Some of you might know the answer to this, but does anybody remember what happened in 1998, what it was like 97, 98 that might have enabled green crab to spread? I think Bob knows the answer to this one.
I heard it, I think.
Oh, yeah?
Somebody.
It was an El Nino. That's exactly right. And that's exactly what pushed a whole bunch of larvae northward. So we have these strong warm currents that are pushing larvae up the coast, keeping the larvae against the coast. So normal conditions, the larvae get just pushed out to sea where they can't survive. But if they can stay against the coastline, they can find habitat where they can live. And it provides them food at the right time. So those conditions are really good for expansion, which, El Nino, where have I heard that recently? Oh, it's been the past 2 years that we've had the strongest El Nino since 97, 98. So you can imagine, and we'll talk a little bit more about this later, that might also play a role in what's going on here locally. So where we're at now, when they established on the outer coast, I've highlighted the places in Washington and BC that they established, Willapa Bay and Grays Harbor out on the outer coast. They've been established there since about 1998, and that was the time that Sean was doing his dissertation work, looking at some populations in Willapa Bay as well as down in California. And this was sort of static for a long time. So this is actually, at this time, is when there was an original monitoring program that was started up that Bob participated in fact. and a really extensive monitoring program that got traps all across Puget Sound. And green crab were never found. It was a successful project in that green crabs were never found as a result of that survey. And our understanding is that ended because of in 2010 roughly, because of the economic downturn, in addition to never having found crabs. I think people started to believe that it was just never going to happen, that there was some natural barrier, that our prevention was good enough to keep them out. They had been looking for more than a decade, and they'd never turned up. Until 2012, when a population was found to be established right here in just west of Victoria in Sauk Harbor. And so this population has been established there since 2012, and certainly having it, this is the first and currently the only known population within the Salish Sea, and certainly having it so close to us greatly increases the probability that we could have larvae washed further in, up and down within the Salish Sea. So everything that I've hopefully just communicated leads up to what is this threat. So we have sort of this, one of the world's worst invasive species. It's now on our doorstep. Is this actually a substantial threat, or are we just being Chicken Little about the situation? Are we crying wolf, so to speak? So I want to walk through what we know about the potential threats to Washington's inland shorelines. And the way I think about this is as an invasion biologist, invasions happen they go through a series of stages. It's not just like a light switch. One day nothing's there, and the next day it's taken over everything. These things happen over time, and different ecological interactions play a role in each of these stages. So this transport stage, will the green crab even make it to inland Washington shorelines? If it does get here, will it be able to survive and reproduce in the habitat that we have available for it? Will it actually become abundant, or will it just sort of maintain these really low population levels? And will it impact local habitats in ways that we care about or can detect? So I'm going to walk through each of these questions separately. One, will the green crab even get here? I mentioned that these are the places on the outer coast it's established, and now we have a population that's very close in. So we could have green crab arriving basically from anywhere. We could have green crab arriving from this close population here, or it could be coming from any of our coastal populations, or actually anywhere else in the world. It still could be exported up here from San Francisco Bay. Now, one thing I think it's worth mentioning right now is that it's not known for sure, because oftentimes you can't tell after the fact exactly how a species got there, but it seems like it's likely that aquaculture operations out here accidentally moved green crabs into Sauk Harbor. So it doesn't seem like this was the result of larvae from, say, Barkley Sound being washed in here. But again, we can't really tell that at this point. So what are we doing in terms of prevention? What are we doing to prevent them from getting here? Well, I mentioned aquaculture is known as a potential vector, a way the species get moved around. So there are much stronger regulations on aquaculture than there ever used to be. It used to be you just put oysters on a ship, ship them across the country, and dump them in the tide flat. Certainly that does not happen anymore. To give an example, as part of my master's work and dissertation work, I collected a species of snail from Willapa Bay. So you go and you get your scientific collection permit, and there's all these conditions on your permit. And I had about 4 pages of conditions on my permit because I was collecting things from Willapa Bay where green crabs are known to have been established for a while. So for instance, they didn't want me to bring any water back from Willapa Bay, which is a little tricky when you're trying to drive snails all the way back up to I was at Shannon Point at the time, to Anacortes. So I had to bring Puget Sound water in big carboys down there to rinse all of my snails off and wet paper towels to ship them back up, because they were worried about green crab larvae potentially being brought back. So they're very conscious of how things get moved around, especially things that come from infested, quote, infested areas. Notwithstanding, I know a lot less about aquaculture operations in Canada than I do here. So I don't know that much about management and gaps in management and how likely that was. Shipping, I also said that ballast water is a potential way they could get here. So the Coast Guard requires all ships to have ballast water management plans. So they have to have some plan in place for how they're going to prevent the movement of species around the world. There are things that they can do, open water exchanges, so they go way offshore, they totally dump their water, and they fill up their ballast tanks with ocean water. The idea is that anything that was living in their tanks won't survive out in the open ocean, and that anything that they pull in from the open ocean won't be something that would invade nearshore habitat. In terms of enforcement, I'm talking to people. Certain people seem to think enforcement's probably pretty good. Certain people think there's lots of ways for ship operators to get around it. If, for instance, if conditions are bad in the open ocean, it's not safe to dump your ballast. So if conditions are bad, you don't have to do that because it would be unsafe. So how much of the time does that play a role? There are some potential gaps, but people are working really hard, especially to address ballast water. This is the way globally that more species get moved around the world in terms of marine invasives than any other way right now. So this is a really important vector for marine species. Yeah, Josh?
So I have a quick question. So these preventive measures are just in the United States?
These are just in Washington State.
Oh, just Washington
yeah.
State. But most countries probably don't have any.
Right. Well, any ships coming into Puget Sound, into any port that we have here, have to play by Washington State's rules. So that's one thing. And any imported shellfish species all has to follow the same rules. So the ports are a really important place for managing the entry of invasive species.
So like this, but in the rest of the world, it's pretty much spreading without any.
Well.
Any regulation or anything.
It's up to the local places to protect their shorelines. I know less about other ways people are.
There are international efforts to manage ballast water. But in terms of the various jurisdictions around the world, and the team buying the newer ships that are coming online now, things like continuous ballast water exchange, where literally, because they're across and they're pumping ballast water all the time, so they have countermeasures in place to neutralize the materials. Lots of different technologies, but older ships, especially the places that don't have regulatory or enforcement actions in place, basically stay.
So those are the things we can exert some sort of influence on. But the things that we can't control are tides and currents. And as you know, there's a very large tidal exchange into and out of Puget Sound daily, twice daily, in fact. And currents, this is the tidal chart, and currents also move, just essentially wash waters around, some of which are well known and understood. So tides and currents are really the way that we are concerned that green crabs could arrive more locally. And the sort of complicating factor is this little guy. He looks kind of innocuous, but he can actually regulate to a surprising extent how much he gets moved around based on how high he is in the water column. So they can drop down close to the bottom and avoid getting pushed out to sea as the tide moves them. And then they can go up in the water column if they do want to get exported or moved on or offshore. So larval behavior in combination with tides and currents makes it very difficult to forecast where larvae, which would be coming out of basically right here on this figure and right here on this figure, where they will end up. So which areas are going to be bathed in the most larvae. In addition to things like the Fraser River input makes a big difference in, especially in the strait, what happens in terms of currents and freshwater lenses. So it's a big open question, but certainly how close it is leads us to believe that it's likely that green crab larvae could get washed further into our inland shorelines. If it does get here, will it be able to survive and reproduce? So the question we have, is there good habitat for it in the areas we're concerned about? One way to try to answer that question is to look at where it lives in its native range. So in Europe here, I've shown you a table of where it likes to live. It does the best along inland shores, regardless of whether it's a hard beach or a soft beach. So soft beaches being sand and mud, and hard beaches being gravel, cobble, bedrock, that sort of thing. In coastal environments, it really only does well on hard beaches. Now, we can also look at other places around the world where it's become invasive. And in some cases, non-native species live in different habitat types in new environments, in new geographic ranges, which kind of makes it tricky to predict. But in this case, in both South Africa and in the east coast of the United States, it has the same habitat preferences as it does in the native range, which would be informative, except what it does here on the west coast of the United States is actually pretty different. And it's restricted, it appears, to mostly soft sediment habitats along inland shores. On one hand, that's good. There are several types of habitat that are not likely to be invaded by green crabs. On the other, how much of this habitat do we have? Well, let's look into that. These are habitats that are characterized by low wave energy, salty habitats like lagoons, salt marsh channels, and impounded tidal areas. When we put culverts in, it slows the water flow in the tidal exchange in a way that makes it good green crab habitat. These are areas that often have a lot of food for green crab. They're very rich. And they also offer protection from predators. And I'll talk about what those predators are in a second. But these sloughing banks, when the tide comes in, the crabs, green crabs can hide in these banks and in this vegetation from any predators that might try to eat them. And then when the tide drops, the predators actually go out with the tide. And so the green crabs can stay wet either by staying in the banks, they can burrow back in the banks, or by staying in the channel itself if it doesn't get too warm there. So these are the good types of habitat. How much of it do we have in Puget Sound? Might not surprise you to hear we have a fair bit. It's part of what makes Puget Sound great. So this is a map that Sean and I created by sitting in a dark room for 24 hours, non-consecutive hours, thankfully. But we flew through the shoreline, flew across the shoreline on Google Maps, looking at the habitats that we thought would make good green crab homes. And we gave them a ranking system based on sort of a little equation that Sean came up with. And so all of these markers are sites that have at least one characteristic of maybe green crabs could make it there, we think, based on where else they're living. But the ones we're most interested in are these orange diamonds and red stars. This is about 176 habitats that we think have a fair shot at being good green crab habitats. And so you can see there's actually quite a concentration in here, less so up here in areas where you get steep, hard shorelines or rocky beaches. And I'll talk about why I think that is in just a minute. So this is a lot of sites. This is a lot of places that green crabs could survive, we think, if they get here. This is just to remind me that this map is on our website. This is like a living resource, and it's fun to check out if you like maps. You can go and you can click on each of the sites and see how we've ranked them, see if there's monitoring going on at them currently. It also has its own direct link that you can go to, but it's also embedded on our website. And we'll take a look at it later.
Sounds like you didn't consider presence or absence of ships in their ballast water.
That's right. That's not taken into consideration here, but it's a good factor that we might think about Everett as having potentially more propagules, and Tacoma as well. Port Angeles that's certainly something we think about, especially as I don't think they do ballast back and forth here on the ferry, for instance, but that type of transportation is not included in this map. Another thing that's not included, but that we sort of think about, is this is the source population or potential. This is the closest established population of green crabs. So if they get washed in with larvae, we might expect these sites to be the most exposed to larvae. And it's something we think about when we're choosing sites, but we don't necessarily have mapped into this equation.
So do you work closely with
We do not work closely with them, unfortunately. We have been really trying to get to Canada to just even go spend time looking at their habitat for green crabs. I am familiar with green crabs from the East Coast. I grew up in the East Coast, and I studied them to a certain extent in Maine. And Sean has worked up and down the U.S. West Coast. Have you been to Barkley Sound at all? Okay. And mostly we hear from them every so often. I think we had an update like this within the last 3 or 4 months, that their population essentially continues to be super robust. If you go to our map, we actually have a little bit more resolution of sites within Souk that they've done trapping and where they found green crab and where they didn't, but those data are from 2012 already, so they're already pretty old, and I'd love to get some more information.
They are doing trapping, continual trapping.
I think they're doing monitoring trapping. I don't think they're doing removing eradication trapping.
So they're not doing any
Control. Very, very little. My impression of what they've been doing is that it's been sporadic at best. There were sort of more concerted eradication efforts, but there aren't, and I'll talk more about this as well, but trapping doesn't really seem to cut it as much as people try. So another way we can think about whether or not green crabs will do well if they get here and they're able to survive is by looking at what's been going on in the outer coast embayments. How have populations been doing? Are they sort of a flash in the pan, or are they sustaining? And there's a woman at Oregon State University who's done a ton of trapping work dating all the way back to 1998 when the crabs first got here. I'm just showing you data from 2012 here, 2002 to 2012 here, where at these sites, which are all color-coded, Oregon and Washington, we have, a peak, some early peaks, and if you might remember, these were actually warm years, so we generally see the crabs do better in warm years around here too. But nothing totally terrifying until we get to last year. So I mentioned the El Nino being good for green crabs, and so certainly last year we saw a big signal of that in her trapping, where we're seeing crabs more abundant than they ever have been at these sites previously. So that is sort of an interesting thing, and it probably will continue this year. This year is the first year since 2010 that green crabs were found in Willapa Bay. And now we're actually already seeing reports from the public, so not just monitoring agencies, but the public is submitting invasive species reports saying they're more apparent in Willapa Bay. In fact, my advisor was out there and she said, I think I saw a green crab, and she described it to me. I'm like, yep, you saw a green crab. So they're much more apparent, meaning that typically happens when there's more of them, their populations are slightly larger. Now, I also want to show you what's going on up here in Canada. So to compare it to what is happening in the US, I'm going to take all of these lines and average them into a single line so it's not so messy. And now I'm going to add lines of 2 sites from Barkley Sound. And when I do that, I want you to keep an eye on what happens to these numbers here on the y-axis. So this is the same person doing trapping, and it's the same units. But there's so many crabs up in Canada that what's going on in here looks like it's a flat line. It looks like we have no crabs, but we have crabs. Our numbers are just much lower. They also, so I only have data that go through 2012. Her most recent report doesn't have information from 2015. So I'm super curious to see if it even would fit on this graph, or if we'd have to make a bigger graph to fit the 2015. But my point here is that even if green crabs were to disappear from our outer coast, if we were to do a really good job controlling them, we would still have a potential source of another invasion out here on the coast of Canada. Now, if they are able to establish and survive and reproduce and carry on a population, will they become as abundant as they are on Barkley Sound, for instance? One of the things that we think about with invasive species about what controls their abundance is whether they have any competitors or predators in the area. Anything that we have living here that might eat them or eat their food and make it hard for them to become abundant. My favorite candidates, as with everything, are large cancer crabs. And it turns out this is good. This is a good idea because the rule of the crab world is big crabs eat little crabs. And these crabs certainly get a lot bigger than European green crabs as adults. So that's good news. We don't expect to see even adult green crabs in areas where we have large adult cancer and Dungeness crabs, red rock crabs and Dungeness crabs. Now, some of the trickier stuff is what happens when the crabs are young enough to be the same size. And what we see here is that it seems to be more of a factor of the crab's behavior type. So green crabs are pretty aggressive crabs, as are red rock crabs. So when these two crabs are the same size, red rock crabs actually win. They will eat green crabs of the same size. However, when Dungeness and green crab are the same size, European green crab outcompetes Dungeness crab for both shelter and food. So the extent to which these populations overlap influence how much our native crabs can control populations of green crabs. But as adults, red rock crabs in particular do a very good job of keeping green crabs out. And some of what we've seen, this is just a sort of a story of one place we've seen that. This is the same woman who's done all the trapping. She trapped all the way up the estuary in Yaquina Bay, so near Newport. She just put out traps just to see which crab species she would catch. And the interesting thing is she only caught one species or the other. She only caught red rock crabs here where it's very salty. In the middle of the estuary, she only caught green crabs, no rock crabs. And then up here, she didn't catch any crabs because it was just too fresh. And what's going on here, she's done other experiments to determine this, is that green crabs could live down here. They're, like I said, they have a wide salinity range. They would be totally happy living where it's mostly marine. But they would try to live here, and rock crabs eat them. So bad news. And up here, this is areas that rock crabs don't like to live because it's too fresh for them. They need that more marine water. So that's essentially a refuge for the green crabs, a place that they can go to avoid getting eaten. Now, I'm going to shift to the question of impacts, and the sort of caveat I want to put out in front of this is that we know that green crabs are likely to have an effect if they get here. We don't know exactly what effect that's going to be, but we can walk through what's happened in some other areas and maybe try to learn something from that. So the first question people almost always have is the shellfish industry going to be hammered by this green crab? Certainly the headlines might lead you to believe that we have something to be concerned about. And you might have noticed that on that list of food that green crabs like, a lot of those things are things we also like to eat. Well, for a number of reasons, shellfish growers aren't all that concerned about green crabs. Part of it is possibly that people were saying for a number of years that green crabs are going to be the worst thing since, fill in the blank. And green crabs never showed up. So there could be a boy who cried wolf thing sort of going on there. The other thing that is potentially a factor is that our shellfish growers already engage in growing techniques that might protect their shellfish from green crabs. So this is a clam beach in Totten Inlet, and the clams here are grown in bags, and that protects them from birds and from native crab predators. So this is how they protect their harvests. If this is done in the right way, this could also protect them from green crabs as predators. Now, the trick here is that if you put your clam bags out at the wrong time, and you put them out at a time when the larvae are all floating in the water, the larvae have no problem fitting through this mesh, and they will actually settle into these bags and grow up with just a buffet. So when you set your clams out is key to protecting this mesh being effective for protecting against green crabs. But this is something that people have learned over time, and it involves sort of some trial and error, but also doing some research about when green crabs are in the water. Another potential effect that's getting a lot more attention recently, especially on the East Coast, is whether or not green crabs could negatively impact eelgrass. On the East Coast, people are doing more research that shows that green crabs rip up eelgrass shoots as they dig for food in eelgrass beds, and they clip off shoots as they're sort of hanging on the eelgrass stems moving through the eelgrass bed. And so there's obviously that could concern us because eelgrass is a very important habitat resource, particularly in Padilla Bay. So will this be a problem here? One thing to think about is the fact that eelgrass might not actually occur at elevations here that are good for green crab. Green crab are really shore crabs. Those large Dungeness crabs and rock crabs keep them pretty high in the intertidal. And our eelgrass actually tends to grow pretty deep. So I think eelgrass on the east coast grows a little bit shallower because of their tides. Their tides aren't as extremely different as they are for us in terms of the higher low and the lower low. So eelgrass can grow a bit shallower, and it might be more likely to overlap with green crabs there than it is here. One question that I have that nobody has done any research on yet, no one's done any research on interactions with eelgrass yet on the west coast here, is whether or not, so as we were talking about, the non-native eelgrass lives at higher, shallower elevations. And those might be some places where we could get green crabs living in those areas. And so I sort of have this open question about whether or not we might see more interaction with the non-native eelgrass than the native eelgrass, and what that means. And then lastly, there are lagoons that are good for eelgrass because they keep water in them all day long, but they're also good for green crabs because they offer protection from predators. So it is possible that where you look for eelgrass and green crabs could affect how much of an impact there is of green crabs on eelgrass, potentially. Again, super open questions, but this is what we think could happen based on what's happening elsewhere. A big part of why green crabs can be so damaging to other habitats worldwide is that they get astoundingly abundant. And Sean's actually going to show you a video during his portion that we just stumbled on yesterday that just really underscores how incredibly abundant these things can be. When something is that dense, it needs to live somewhere and it needs to eat something. So you can imagine that by just doing that, just making a living at that density, you're going to have a substantial impact on a habitat. Now, in terms of what those effects might be, we're talking here more or less about ecological effects rather than economic ones. What are the things that are living in habitats like these that we think green crabs would want to eat? Primarily, they get a bad rap because of their role as a predator. Now, we've trapped in places like this. In fact, we trapped in this very exact place. And when we put traps out and collect things that live in places that we think would be good for green crab, the most abundant thing that we catch is this guy. This is our native hairy shore crab, which looks really cute and defenseless in that picture. I assure you, those claws do pinch. But this is a crab that is really abundant in these habitats. It doesn't get as big as green crabs, so we think about green crabs potentially eating it. And in addition, there have been sort of these bucket experiments where you throw a green crab in a bucket with one of these guys, and sure enough, the green crab is happy to eat our native shore crab. How that will play out on a tide flat is a much more complex question, but it's the possibility is there that this is a species that could see major impacts from very dense green crab populations. And of course, those impacts aren't going to be restricted to just this species. Everything that the shore crab interacts with will also be impacted by reduced shore crab populations. So it's these ecological ripple effects that sort of cascade out into the community.
Crab maybe question.
Yeah, sure, please.
Why is this little guy called a hairy?
That's a great question, and I'm sorry, Sean, to blow your punchline, but the hairy shore crab, you can actually see it in this picture, has hairy legs, and that is a key identifying feature. Yes. The European actually does have some hairs on its legs, but you see, the thing with common names of species is that they are only helpful within the context of where things evolved. So, funny story. In its native range, the European green crab is not called the European green crab; it's called the shore crab. We also call these shore crabs, and actually one of the common names is green shore crab. So this is, why this is potential to be very confusing. But Sean will march you through very systematically just exactly how to tell them apart, because they can. It's not impossible to imagine how you could confuse them. So to summarize about the threat in terms of, is the threat oversold or should we be worried? My conclusion is that yes, it is oversold, And there is also a legitimate threat from this species. It might just not be the effects that we've seen in other areas of the world. So what are we doing about it? Well, that's part of why we're here today. And the good news is that, as I said before, invasions don't just happen like a light switch. We have the advantage that green crabs aren't here yet, and that in the world of biological invasions, we're in a really lucky place because we have the opportunity to act before it gets here. So invasions do play out over time, where there's this time scale where they're absent, then they're introduced, and they're typically introduced as a very small number. So it takes them a little bit of time for them to grow their population before they get as abundant as we saw in those pictures. Now, so there is this time of first arrival. One of the things about invasions is that we don't usually notice the invasions until they're well into this really fast population growth phase. And the reason that that's bad news is that the cost of managing invasive species increases with how many invasive species there are. So that sort of makes sense. The more there are that you're trying to control or get rid of, the more expensive it is to take care of it. But what this also means is that the most cost-effective time at which to intervene in an invasion is before it even happens. That's also the time when you can prevent any ecological damage. So that's obviously the sweet spot. We're working on it. I talked about some of the measures that are taking place, but there are some things we cannot control. Now, when invasions very first start and we have small numbers and relatively slow population growth, eradication is technically still possible. It might be a whole lot more expensive than prevention is, but it's still theoretically feasible if we put enough effort into it. However, once we get into this rapid population growth phase, at which point, this is the point when we usually first notice invasions, because we're usually not looking for them before they start, it gets a lot more expensive, and we just really switch our strategy to just trying to contain them, keep them from spreading to new areas, and control the population. And once we get to sort of this end stage here, we tend to shift our money and our investment in control to protecting resources rather than managing the population. So there's really kind of this missed opportunity here in terms of when we first notice invasions, and I'll talk about that. But first, we hit on this earlier. What are the options we have for controlling green crab? Well, we mentioned trapping. Trapping unfortunately hasn't been shown to really decrease crab populations. In Massachusetts, there are 5 state-funded bounty hunters whose job it is exclusively to go and collect these crabs. I actually don't know what they do with them when they pull them out of the water. They're trying to create markets for green. Well, yeah, I'll talk about that in a second too. Nevertheless, these 5 people have been working for several years trying to pull green crabs out, and they're not seeing decreases in numbers. There was so there's been sporadic efforts on the west coast of Vancouver Island, but again, not making a dent in the population. They come back the next year and they're back. So another strategy is, okay, if you can't beat them, eat them. And this is European green crab. This is what it looks like when it's cooked. So they're eaten in the native range. They make stock. They're kind of small, so you can pick them, but it's not like picking a Dungeness crab. It's hard work and low payoff. You can process them as soft shells. They are harvested in the native range as a fishery. They're managed as a fishery, so it's theoretically possible to do here as well. The other suggestion is that you could use them as bait. So you trap a bunch, use them as bait for lobsters. So 2 cautions. One, the bait one first. In, I think it's Newfoundland, they were doing this. They started noticing that the lobsters that they were bringing up for which they had used green crab for bait had a higher incidence of specific diseases and parasites that can also be vectored by the green crab. And this is a really early days research, but there's some evidence that the green crabs as bait could be causing increased incidence of disease and parasitism in lobsters. So there's enough to sort of caution that might not be a good strategy for getting rid of green crab. The other thing is more of this economics explanation of when you create a market for something, you're disincentivizing eradication. So anybody who's now fishing this to make money doesn't want to see it go extinct because there goes their income. In fact, the bounty hunters in Massachusetts, this kind of like baffles my mind, the sort of cognitive dissonance of this. The manager who assigns ranges to the bounty hunters says that he doesn't want to hire more bounty hunters because then the ones who are participating wouldn't have as much of an incentive to participate because there's fewer and fewer crabs. So, it's sort of this chicken and egg economic situation that once you put economic value on something, there's less reason to get rid of it. So it's a caution. It doesn't mean that we shouldn't eat green crabs if we catch them. A third option that often comes up is to get another organism that we bring here to do the dirty work for us, to be so usually that's a parasite or a predator or disease. I can see people shaking your heads, and that makes me glad. So the candidate here in our case is this. This is actually a parasitic barnacle of all things. This species of barnacle occurs in the native range of green crabs, but didn't come to the east coast or the west coast of North America. We have other parasitic barnacles here. It's not, to my knowledge, it's not known, or I'm not aware of whether or not they also infect green crabs, and that's kind of an open question. But the problem here, thankfully they did their research and they found out that this species of barnacle would actually potentially infect our other local crabs. So they're not going to bring it here, which is good. This just, fun David Attenborough sort of zombie parasite fun fact of the day. This infects the crab and sends it looks like roots of a tree all throughout the crab's body. It secretes, I think it's essentially mimics hormones of an egg-bearing female. So whether or not the crab that's infected is a male or a female, it thinks it's carrying eggs. So they aren't reproductive. So this essentially castrates the crab. It's a cool biology story.
Yeah, and you probably know that in this region we have another barnacle that behaves just the same on crabs.
Yes, yeah.
Including the sex change.
Exactly, yeah. This group, rhizocephalan barnacles, there's some that infect shrimp as well. And so we don't know how that would interact with green crabs, but we do know we don't want to bring a species of barnacle that's not familiar to our native crabs in that could be much worse for them. Maybe their immune system can't fight it as well. Those are the types of things that we don't want to do. So this is not a good option. And
Sorry.
no, it's okay.
Is that barnacle like one of the predators?
It is a control on their population, exactly. So one other thing that's interesting is that green crabs in the native range don't get as big as they do here. They grow larger here, and part of the explanation for that is because they don't have to contend with this barnacle. It's kind of a common theme in invasions that sometimes species are more successful in their new range than they were in their old range in terms of just individual fitness, size, and reproduction, as well as overall abundance. And sometimes the explanation for that is that their diseases and their predators they left behind, and they don't have to devote energy to those. They, of course, potentially face new diseases and new predators, so it's kind of unknown outcome, but that is a control on their population in the native range. So we don't have a lot of really good options. So if we get to this end stage here of invasion. So what have we done in terms of prevention? Well, I talked about sort of ballast water and aquaculture. The other thing I want to point out is that in Washington State, green crab is a prohibited species. It's illegal to have it, to possess it, to sell it, to ship it, to transport it, and certainly illegal to release it into state waters unless you have a permit. You will not get a permit to release green crab into state waters. That's just no one's going to give you that permit, and it carries a pretty hefty penalty. Our volunteers carry a permit that we get from Washington Department of Fish and Wildlife to possess green crabs, and so if ever you were approached on the beach by a DFW agent and he says, "Why do you have that green crab, sir?" You say, "Because I have a permit." So in theory, you can go to Carolina Biological and buy live green crabs and have them shipped to you. It's not legal to have that happen in this state. They were actually marketed. I don't know of people who keep them as pets. They're kind of, you would have to really love green crabs to want them in your fish tank, and I don't. Yes, people have very strange pets, but they were sold for a long time as educational. They're very hardy crabs, so they're easy to keep in tanks. Like they don't mind dirty water and poor water quality, so it's easy to keep them in tanks. So people use them for education and developed curriculums around studying the physiology of a live crab. It's pretty interesting. So you can get them from biological supply companies, but not in the state of Washington. It's illegal to do so. So we talked a little bit about prevention, and we talked about containment and resource protection. What we're actually trying to do here to address the threat now before it gets here is advance this stage of public awareness, to move public and manager awareness to a stage of the population growth to where eradication is still feasible, captured at the earliest possible opportunity. So we're interjecting early detection between prevention and resource detection, knowing that we can't put together a perfect protection plan. And what this means, since we have so many sites, is actually going out and talking to people, putting eyes on the beach, and getting boots in the mud that will enable us to maximize the spread of our search efforts. So Eyes on the Beach is, some of you actually may have been present for talks that we gave earlier. We were at Sound Waters, which is where we met Bob, and talking to the community of people who's already out in these habitats, looking at the shoreline. We have people helping me with my research. We have people looking at dead birds on the beach, people looking for live birds, and people who are invested in these habitats, so telling them what it is that they should be looking for, and then how to report it and take care of it if they find it. And then the other half of the equation is actually getting our boots in the mud. This is where we're going out and we're targeting sites that we think are good habitat for green crabs, and we are actively looking and trying to anticipate their arrival. And to give you the 30,000-foot view of what that looks like, we work from April through September. This is the period of the year when crabs are most actively foraging, and so they're attracted to bait, and they're most actively growing. And we train volunteers to conduct searches at high-risk sites. So we're targeting those red and orange sites on the map mostly. And we conduct baited trapping, so we're trying to attract the crabs that come in. We conduct molt hunts. One of the interesting things about green crabs is that they're first identified in a new area more often as molts than they are as live individuals. So molts are actually a really powerful detection tool. And then we also collect information about shoreline features like vegetation and other things that are living there, so that we can tell something about the health of that site, and we might be able to look at it before and after green crabs come. So if we compile all this information, what we have is the greatest chance of finding green crabs early when we can still do something about it. We can also learn about what the effects of the green crab invasions are. Some of you, myself included, might have been a little disappointed when at the section where I was talking about what will the impacts of green crabs be, and it's because we don't have a lot of information to be able to say with any certainty, and a lot of it is hypothetical based on what we know at other areas. So what we really need is data before and after green crabs come, at areas where they are and areas where they aren't, and to be able to tell us how are other populations being affected by green crab presence. And then lastly, and not least for being last, this is really a project that is about tracking the health of pocket estuaries. A lot of the places that are good green crab habitats are these small backwaters. I don't mean to insult them by calling them that, but they are really small, isolated habitats that are not well studied. When we think about the areas of marine habitat that are well studied, we're thinking about the classic rocky intertidal. We're even thinking about sandy beaches where people spend a lot of time because it's beautiful, but a lot of these sometimes soft sediment habitats that are muddy are a little bit less sort of, there's fewer boots in the mud. Let's put it that way, to use an expression. And so there's less known about these populations. So we're talking about the short crab, which is certainly the most conspicuous and abundant marine organism there, we know a whole lot about the physiology of short crabs. We know about their respiration, their reproduction, how they regulate the temperature, the salinity of their body fluids. But we don't know a lot about their populations and what their populations respond to. So this is about assembling a long-term data set that's not just checking a box, yes or no, is green crab there. It's about looking at everything that's there to learn not only about green crabs, but how these habitats are responding to shoreline development, to upland land uses, to ocean acidification, sea level rise, sea temperature increase. All of the threats that every marine habitat faces is also being faced by these really productive, important habitats, only we know a lot less about them. So I'm putting a heavy plug for this as a very important component of this project. I mentioned we started last year as a pilot year. There's available a pile, and I just shown it up here for reference, of quick little summaries of what we found last year. We had 7 sites going at different areas of the sound. We captured more than 8,000 organisms and counted them all. This does not include the molts that we found, so this is a lot of things we counted. 0 of them were green crabs, which is good. To date, green crabs have still not been reported along inland Washington shores. They've not been confirmed as being present. So this year, we're hoping to expand to up to 30 sites across, and I won't go through all of the details of the different places we're adding sites here, but I can talk to you about it at some other time. So expanding all of this obviously requires that we get the help, enlist the help of a lot of volunteers to help us look at all of these potential invasion sites and to keep an eye on them and the health of the pocket estuary as our army of trained volunteers. So do you guys have any questions about things I've talked about so far? I'd love to take a break now and then transition into learning from Sean about. Yeah, I wish I had put one on this slide, but I can. Well, the best predators we have are native crabs. So our large cancer crabs, but in addition to those, there are others, also not on this slide. Our sculpins are likely to eat them. There are some larger fish. Sean can actually probably answer this question more fully than I am because I don't know from fish. And so there are some fish that will eat them. We also do see gulls that will attack them as well. I don't know whether herons will tangle with them. Yeah. What's up? Yeah, we did. Presumably he'll be back in 15 minutes. But yeah, let's ask Sean when he gets back. Any other questions? Also happy to just be available to chat during this time. I'm not going anywhere. All right, well, why don't we take a break for about 10 minutes, grab some coffee, and we'll have Sean start in about that time. At exactly that time, I mean.